Today we're going to be learning about proportions and similar figures. So our success criteria today is for you to solve proportions, which we're going to go over those steps, and for us to create proportions for similar figures and then solve them. Okay, and it will make more sense in a minute. You guys did have vocabulary on this, so for solving proportions, we cross multiply. And then we solve the resulting equation using our 6-step equation solving process, the process that we've been using for the past 6 days. Okay, this whole unit. So, our first step is to cross multiply. So I'm going to multiply x times 5. And what's x times 5? It's 5x. And I'm going to multiply 4 times 8. And what's 4 times 8? 32. Then I'm going to solve using my 6-step process. So I'm going, there's no distributing, there's no fractions, there's not a variable on both sides. So I'm going to divide to get the variable by itself. So I'm going to divide by 5. And normally we would leave this 32 over 5, but because this is a proportion, and proportions usually represent real world situations, we can actually put this as a decimal. So what would be 32 divided by 5? 6.4. All right. So I'm going to cross multiply. So 4 times x. What would be 4 times x? 4x. And then I'm going to multiply 5 times all of this. So I'm going to do 5 times 3 plus, or x plus 3. Okay, and that's going to be, we're going to have to distribute now. You should be writing this down, guys, as I go. So I'm going to distribute my 5. So I'm going to get 5 times x, which is 5x. 5 times 3, which is 15. So now that I distribute, I have no this is from last, we picked them up last week. So now that we have distribute, we are going to, we don't have fractions, I don't have like terms, so I'm going to move my variable. I only have one variable on this side, so I'm not going to move it even though it's smaller. I'm going to move the 5. Okay, it doesn't matter which variable you move. It just, usually the smaller makes it easier. But in this case, we have to move our 5x. So I'm going to subtract 5x from both sides, and I'm going to get negative 1x equals 15. Okay? Then, is my x by itself yet? No, there's a negative affecting it. So I'm going to divide by negative 1. So x is going to equal negative 15. So we only added one additional step, cross multiplying. Alright, so we're going to cross multiply here. I have n times 6, which is 6n, and I have 5 times 2n plus 4. All of this has to get multiplied, so 5 times 2n plus 4. I prefer if you guys don't skip the step of writing this out. You want to make, because if I just multiply 5 times 2n, that's not going to give me the same answer. I have to make sure I multiply 5 times 2n and 5 times 4. So writing it out like this makes it easier, that I know that I have to distribute. So I'm going to distribute my 5, and I'm going to get 10n plus 20. Just like the last problem, yes, 6n is smaller, but it's only on, that's the only thing that's on that side. So I can't, not that I can't subtract 6n, it's going to cause more steps if I do subtract 6n. So I'm going to subtract 10n because it's going to cause me to have less steps. 6n minus 10n is going to give me negative 4n equals 20. Then I'm going to divide by negative 4. So I'm going to get n equals negative 5. Right, for this one, I have 2 sets that we're going to be distributing. So c plus 1 is all going to get multiplied by 7. So that's going to be 7 times c plus 1 equals, and then we're also going to be multiplying 4 times c minus 2. So 4 times c minus 2. So I'm doing double distributing. So I'm going to do 7 times c, which is 7c, 7 times 1, which is 7, 4 times c, which is 4c, and 4 times negative 2, which is negative 8. Right? Because I do have a variable on both sides and I have a constant on both sides, this is when we would want to move the smaller of the two. So am I going to be subtracting 7c or 4c? 4c, which is going to make it easier for me. 4c from both sides. So 7c minus 4c is going to give me 3c. Then I'm going to subtract 7 from both sides, my constant. So I'm going to get 3c equals negative 15. Then I'm going to divide by 3. So c is going to equal negative 5. We're going to do this your turn together, but I'm going to need your guys' help. Okay, so what's the first thing I'm going to do? Yes. Cross multiply. And can somebody tell me what I'm going to cross multiply? Yes.
X times 4 and 11 times 2.
Yeah, I'm going to multiply x times 4 and 11 times 2. So what is x times 4? 4x. And what is 11 times 2?
22.
Now what am I going to do? Yes. Yeah, divide by 4 to get the variable by itself. So this cancel out, leaving me with x equals, and because it's a proportion, we can use a decimal. So what would be 22 divided by 4? 5.5. Because we wouldn't say we had 11 and, or 20, yeah, 11 over 2 cups of rice, would we? No, we would say we had 5.5 cups of rice, something like that. Because that's what proportions usually represent, a real world situation. So decimal is fine. All right, so can somebody help me with this, setting up my problem? What am I going to do first? Cross multiply. So what am I cross multiplying?
3 times t plus 3.
Right.
5 times t minus 2.
So I have 3 times t plus 3 and equals 5 times t minus 2. Okay? Now what do I need to do? Distribute. So I'm going to distribute my 3. So I'm going to get 3t plus 9 And I'm going to distribute my 5. I'm going to get 5t minus 10. Now what do I need to do? I hate t's.
You can make them capital too.
Well, in variables you normally don't use capital letters unless it represents something like time or speed or area. Okay, so what are we going to do next? Jordan? Am I going to subtract 5 or am I going to subtract 3? Which one's smaller? Alright, so I'm going to subtract 3t from both sides. We could do the 5. It wouldn't actually change anything. You would still get the same answer. We're just going to be dealing with negative numbers. And I don't like negative numbers. So if you have the option of moving the smaller, move the smaller. So these cancel out, and I have 9 equals 2t minus 10. Now what do I need to do? Yes?
Oh,
Were you raising your hand?
no, but you can do minus 9 with 10 minus 9. I don't know.
Yes?
Add the 10 to the 9.
Okay, I'm going to add 10 because I have to eliminate the 10. I'm trying to get everything away from my variable. So I'm going to get 19 equals 2t. Now what do I need to do? What? Divide by what? 2. And what is 19 divided by 2? So t equals 9.5. Yes. Majority of the time, you're not going to use decimal, only with portions, okay, or real world problems, word problems, okay? And you could leave this as a fraction, and I would not care. I would still, you'd still be correct. So when in doubt, leave it as a fraction, unless it's a word problem. You wouldn't have 19 over 2 cups of rice, would you? No, you'd have 9.5 cups of rice. Does that make sense?
So when we're doing these, do we leave what decimals?
You can put these ones as decimals. Okay, portions can be decimals because they represent something that's going to be a real world situation, and you'll see in our word problems next. Okay. However, if you don't know if you should be leaving it as a decimal or not, leave it as a fraction. I won't count it as incorrect. Okay. Word problems are always decimals though because they represent a real thing. Alright, so let's try word problems. So with a word problem, you use the first set of information being compared to write your first fraction. Okay, then it's going to equal the second set of information that you're giving. The key thing here is that it has to match. So if our length is on top, on the other side the length has to be on top. If the width is on top, then the width has to be on top on the other side. Then we're just going to solve the proportions like normal. So let's practice one. So for example here, he says you want to make a scale model of a parade float. The float is 5.5 feet high and 10 feet long. Your model will be 14 inches long. How tall should it be? So I'm going to look at my steps, use the first set of information being compared to write your first fraction. So the first set of information that's being compared is 5.5 feet high to 10 feet long. So do I want my height or length on top? It doesn't matter. Height, let's just say height. So I'm going to do height over length. So if I'm doing height over length, I'm going to have 5.5 over what? 10. Then that's going to equal my second set of information. The key thing is that I have to match my height and my length. So do I know my height of my model? What are we looking for? How tall? So do I know the height? No. So that's going to be represented by a variable, x. That's the unknown. That's what we're looking for. Then do I know the length? Yes. 14 inches. Okay? My length goes with my length. My height goes with my height. Okay, now that we've set up our problem, we're going to cross multiply and solve. So I can do 10 times x, which is 10x. 5.5 times 14, 77. Then I'm going to divide by 10. And x is going to equal 7.7. Because we wouldn't say 7, we wouldn't say 7 points, or 77 over 10 for this. Like, that doesn't make sense for length. We would do 7.7. And what is this? It goes with my model. So what unit of measure are we doing? Inches. Because our parade is in feet, or the big float, and then our model is in inches. So this would be 7.7 inches. It's important to keep your unit of measure in mind, because they might try tricking you. So let's do another one of these. Alright, so we're making lemonade. The lemonade recipe calls for 3/4 a cup of lemon juice for 2 quarts of lemonade. Okay, let's stop there. I need to make my proportion. Okay, what do I want on top? Lemon juice or lemonade? Lemon juice. So let's just say lemon juice over our lemonade. Okay, so I have 3/4 a cup over, I know this is going to look weird, how much lemonade? How much lemonade? 2 quarts. Okay, now I'm going to, it says how much lemon juice would you need to make 5 quarts? So do I know my lemon juice? No, so that's going to be my x. Do I know how much lemonade I'm looking for? Yes, that's going to be 5. All right. Now we're just going to solve here. So I'm going to multiply 2 times x and get 2x, and 3/4 times 5, which I'm going to get 2x equals 15 over 4. Okay, I'm going to leave it as a fraction for now, because cups, do we say like 3.75 cups? No, we do like 3 and 2/4, or not 2/4, 1/2, or 3 and 1/8 cup, things like that. So we're going to keep it as a fraction here. Not, if you did it as a decimal here, this word problem is fine, but normally we do fractions as, or cups and stuff are going to be as fractions. So I'm going to divide by 2. I know this looks weird. So I'm dividing 15 by 4 and by 2. Okay? So I can multiply 4 times 2 and get what? 8. So this would be the same as x equals 15 over 8. But I wouldn't say 15 over 8 cups, would I? I would make this into a mixed number. So what would be my mixed number here? 1 and 7/8 cup. So I would say I need 1 and 7/8 cup of lemonade, or lemon juice. If you did it as a decimal, that would be fine as well. I would be okay with that, because this is a word problem, and 99% of the time you use decimals for word problems. Okay, so let's talk about similar figures. This is not anything new or different than what we were just talking about. The only thing that's here is they're going to be giving you pictures, and we're going to create our proportions with our pictures, okay, with figures. So the key information here is that similar figures are the same shape, but not necessarily the same size. Similar figures have congruent angles, and similar figures have sides that are proportional. So if they're proportional, then we can set up proportions to find missing sides. And that's what we're going to be doing. So we're going to use proportions to solve similar figure problems. We're going to match the corresponding sides of the figure to create a ratio. Then we're going to solve the resulting proportion. Okay? So the only thing that's really different here is that we're going to be looking at images, shapes. So, for example, here I have two shapes. They're the same shape, but different sizes. This length here is 15 meters. This length here is 25 meters. The corresponding side to this figure, the 15, is 3. And the corresponding side to this figure would be x. Okay, so the first thing I'm going to do is set up my proportion for this figure. Okay, so I need to put 15 over 25 or 25 over 15. It doesn't matter. Okay? So let's just do 15 over 25. My other figure is going to be my other proportion. Which side matches with 15? What's the length? 3 or x? 3. So my 3 is going to go on top. It needs to match. Okay? Then, which side goes, what's the variable that goes with my 25 on this side? X. So I'm going to set up my proportion, because these lengths, these sides of our figures are the proportion sides. So now I'm going to multiply 15 times x and get 15x. 25 times 3 and get 75. Divide by 15. Divide by 15. And what do I get? What does x equal? 5. Yep. 5 meters. Alright, so these two figures are similar. It's letting me know that these two figures are similar. Okay? However, they changed the orientation of this figure. They flipped it around. So I'm going to first create my proportion with this one. Do we want to do 6 over 10 or 10 over 6? Let's do 6 over 10. Doesn't matter. All right. However, what does matter is what goes with the 6. Does my x go with the 6 or does my 5 go with the 6? X, because it's the side that is similar. Okay? And then what goes with my 10? 5. Yeah, they flipped around the shape, but 5. So I'm going to multiply 10 times x and get 10x. 6 times 5 and get 30. Then I'm going to divide by 10, and x is going to equal 3 centimeters. Okay, let's try the next one. So, I have two triangles inside here. I have a small little triangle and then a big triangle. Okay, I'm looking for this side here, my x. So let's set up my proportion for my big triangle. I'm going to have 4, right? Then what is going to be my length here? 5, because it's 2 plus 3, so it's going to be 5. And then that's going to equal, is my x going to go on top or bottom? What does it correspond with, the 4 or the 5?
4.
The 4, so it needs to go on top. It goes with the side that we're looking for, okay? You see how I have a 4 on the bottom here? This is also the bottom. So we want to make sure that you have it with the one that it represents. Then on my side here, what am I going to have? What's my side length for my small triangle? 3. So then I'm going to cross multiply 5 times x and get 5x, and 4 times 3 and get 12. Divide by 5, and what's 12 divided by 5? 2.4 meters. Okay. Okay, for the second one, I'm looking for how tall is the tree if Susie is 5 feet tall. Okay, so Susie here is 5 feet tall. Her, to the end of her shadow, is also 5 feet. So this proportion here is going to be 5 over 5. Now I'm looking for the tree. So that is going to go with Susie's height, 5. So that's going to be on my top. I'm recording. Then our base here is going to be 10 plus 5, which would be 15. So then I'm going to cross multiply 5 times x and get 5x, and 5 times 15 and get 75. Then we're going to divide by 5, so x is going to equal 15 feet.